let me introduce the third speaker in this conference is Ken Finnigan. Ken is a senior principal software engineer for Red Hat, and he has been a consultant and software engineer for over 20 years with enterprises to the whole world. He has a history of delivering budgets on time and budget across many industries, delivering key customer value. Ken has currently focused on all things observability while also looking to innovate with Kubernetes native development. So he's a part of team development Quarkus to be Supersonic Subatomic Java. Ken has previously served as the project lead for Small I, Tron Tai, and Live Oak with over 10 years of experience contributing to open source. He's author of several books, including Kubernetes Native Microservices with Quarkus and Microprofile and Enterprise Java Microservices. This session will cover why observability is important in the cloud and how to go about it in Kubernetes. So, welcome, Ken.
Thank you for the introduction, Sanju.
Yeah, thank you.
It's great to be here.
Yeah, great. Great to talk to you. Yeah.
Cool. So as Sanju mentioned, I'm here to talk about observability today with a particular focus of what's possible in the cloud with Kubernetes. So Sanju kind of mentioned a lot of this already, but just quickly, yes, I work on the Quarkus project for Red Hat. And for the last year or so, I've been focused on the observability side of things, mostly around metrics and tracing. And there's some particular work I've been doing around open telemetry, which is something I'm going to be showing today as well. So first of all, let's talk about observability. What is observability? So in many respects, the term is highly overloaded. There is obviously from many years, decades even, we've had the term monitoring, which is usually associated with anything related to keeping systems running. So that might be metrics around like processor usage, memory usage, the number of nodes available and things like that. Typically, this kind of monitoring shouldn't be something you have humans looking at. I know maybe a couple of decades ago, you would have people just operations just watching huge screens with all these metrics flying by, and that's what they did. These days, we've got a little more advanced, and we have alerts for those kind of things to let people know that something needs to be looked at so that they're not having to look at a dashboard the whole time. But observability goes beyond that even more. It's the ability to ask any question of a system based on the data you have at hand. So in that respect, monitoring is more about the known unknowns. And by that, I mean, you know what things to measure, whether it be metrics, logs, or traces, to then be able to diagnose through that output when something goes wrong. But observability is being able to answer the unknown unknowns. So you don't know what kind of question you might need to answer. So therefore, you can't predict what kind of information you need to get out of a system. But you need to be able to investigate the system with the data that's there to try and determine what's going on when something bad happens that isn't an expected case. And observability is also particularly critical for business outcomes. By that, I mean being able to monitor the business. So for example, if you're Starbucks or Cafe Nero or any of those places, you want to be measuring the amount of particular kinds of coffees you're selling, the amount of time it takes to refill black coffee, for instance, and all those kind of metrics. So those are important from a business perspective, but not really from a keeping the system running. And so who does the observing? Well, it kind of depends on the environment. So traditionally, that would have been operations, though they would have obviously been focused on monitoring in the past. But these days, it can be mixed operations. It could be SREs, or it could be DevOps. So it's developers themselves doing that monitoring. They are typically, or at least that aspect of it is often focused on keeping the lights on. Now, there's also another group which also includes SRE and DevOps, which are, and also developers and product managers, but they're looking at the business outcomes of, is my service giving me the business value I expect? Is the amount of, for instance, like sales on an e-commerce site, is that going up or down? And being able to measure and monitor these things in conjunction with things like A/B testing, canary releases, so that you can make decisions about what to do based on the data you're seeing from your observability platform, and not just kind of guessing as to what's the right thing to do. So we have some developer concerns around observability. A big one being like, who's monitoring my service? So we discussed a couple of groups on the previous slide. That kind of changes what kind of information you're making available. So for instance, for an operations focused group, they don't need to be knowing like the business level metrics that your service might produce. They're only concerned with like the HTTP request latency and throughput and the memory allocation and things like that. Another important aspect is, does the telemetry that we produce from a given service align with others? So when we have our own service and it's on its own, it's our own thing, and we're the ones responsible for it, there's no real need to get any aggregated view across many services. But as soon as our service is part of a distributed architecture that may have tens, hundreds, or even thousands of microservices all working together to achieve an outcome, it's very important for the operations side to be able to get that holistic view across all those services around what are the kind of memory utilization, CPU utilization, all those critical figures for any given service, but aggregated so that they're not having to look at each specific service individually. They can just look at them all and see the spikes where necessary, and then drill down into, okay, which service is having a spike here. So to be able to do that alignment across many services, it means that everything needs to be named the same. Otherwise, there's no way to do that. And that's where OpenTelemetry comes in as a key factor in its definition of semantic conventions, which we'll talk about a bit more later. But they're working really hard to align what we call these things, whether it's the name of a metric, the name of a span, and what attributes or labels are attached to each of those, to make sure that it doesn't matter whether a service is written in Quarkus, Spring Boot, Vertex, or even Node, Go, Python, that they're all outputting the metrics with the same names so that the aggregation can happen from an operation perspective. Now, granted, there will be some things that don't make sense across all services, but there are still a lot that do. And the key aspect here is what metrics are needed for uptime monitoring, to operations being able to say these services are working okay. So it might require separating which metrics are shipped off to the monitoring systems for operations and which are shipped off to monitoring and observability systems that DevOps, SRE, or application developers themselves would use. So that's a bit about what observability is, but why do we need it? Well, obviously, in the past, when we had monoliths and more traditional applications, that everything was in this one bucket, and maybe you had a couple of servers, maybe a handful at most, that were clustered among themselves. So there was a very small number of instances, and it was very easy for operations to monitor those half a dozen physical machines or even VM instances to make sure that they're all running okay. The problem then becomes when you split that out into dozens or hundreds, there's just no way to do that at the same scale that it was done before. So we need a better way to look at a more holistic view. And in addition to that, with distributed systems, whether they're microservices, serverless, event-driven, or any new buzzword that might come along in the future, with this large number of interconnected services, it's more difficult to diagnose what's going wrong where because we're so disparate. The ability to debug in and see what's going on in a single all-encompassing application is a lot easier because everything's in the one place. You can step through things, you can watch the logs and get an understanding of particular requests that are coming through and what's happening with them. But when they're spread across many services, you don't necessarily know which service to look at to start with. And even if you look at one service and say, okay, this one's acting weird, you might look into it and go, well, okay, this one doesn't have a problem, but it's because of something else it relies on that has a problem that is making this one act weird. So it's very difficult to get that holistic view. And then you throw in network failures as well, and it becomes even more complex to get that really good understanding of your distributed system. So observability is kind of the thing we want to do, but to be able to do that, we need telemetry. So traces is probably, along with metrics, is one of the more well-known pieces of telemetry. It provides a visualization of events across time in their order. Now, each trace can have a tree of many points which are spans, which are each individual events across the life cycle of a particular request. They usually also have information around what that particular request is about and how long that request took and other pieces of information which is critical for diagnosing. Another one is metrics. So that's a point-in-time measurement of an instrument. And it usually has a bunch of tags or labels, depending on what nomenclature you want to use, associated with that metric to be able to provide, as we were talking earlier, a reusable and common name for a particular metric to get that holistic aggregated view, but then being able to dive down into particular labels on that metric to get a more detailed view for a specific service or specific parts of a service and to see how they're acting. Now, this is a little different than traces and spans in the sense of for a given request, you might see one, maybe a couple of traces, but it could have several spans. With metrics, you could potentially have anywhere from dozens to hundreds of metrics from a single request. So the explosion of data is very real and is certainly a problem that needs to be considered. Throw in the problem of cardinality with time series databases, and it becomes even more so. So as an example there, if you're attaching a label or tag with a user ID onto any metric, then that will create a whole new time series every time that user ID is different, which may not be what you want. Conversely, on a service name, that doesn't change as much, so you're getting less time series instances created from each of those. And then our old friend logs, often unstructured, although some will have started using structured JSON to provide a better view on that information and being able to use tools other than just grep to find things in the logs. There's certainly a kind of poorer cousin to traces and metrics in that they're usually not linked to traces or metrics, so there's no correlation between them. There are ways to create that correlation, but it's not something that usually happens by default. And they're often very noisy, so it's very hard to see, looking at logs, what's going on compared to traces and metrics. So how do we measure these things? So I mentioned OpenTelemetry before. It's a fairly new, well, maybe 18 months old, an initiative to combine open tracing, which was purely tracing, and open census, which was metrics, into an all-encompassing set of specifications and projects around all telemetry that are needed. So metrics, traces, and logs as well. They've defined are defining a series of semantic conventions around naming of these metrics and traces and logs, and what should be contained in them, how they should be named, what are the possible values. So this gets to the being able to align these metrics across many different services. Once these services start implementing OpenTelemetry semantic conventions, then we can get that aggregated view a lot easier than we would have been able to in the past. They've defined a cross-language API specification, and there are many different language implementations I've been working with the Java one, but there are many others for like Rust, JavaScript, Node, Go, Python. There's a ton of them. They've also defined a common collector. So for receiving traces, metrics, logs, for transferring to any kind of backend. So this is, for those familiar with open tracing, this is a little bit different in the sense that with open tracing, it defined an API, and then you needed a client library like Zipkin or Jaeger that implemented those APIs to actually have anything happen. With open telemetry, they also have an API for interacting with the traces and spans and also metrics, but the implementation of that client library is actually in OpenTelemetry itself. They have an SDK, which is their implementation, and that provides the meat behind the APIs to actually make things happen. And then they offer these exporters to export that information, whether it be traces, metrics, or logs, to a different backend, or whether it be the common collector or a Jaeger collector, or there are many different collectors around as well. In terms of where they're at, tracing went GA maybe 6 weeks ago or so now, so it's still fairly new. Metrics and logs are still being worked on actively, but they're making fast progress there. Specifically for the metric space with Java, there's also Micronaut, which was released in 2017. It's become kind of the de facto standard for metrics in Java. Spring and Spring Boot use it heavily. Micronaut uses it. We've now introduced it in Quarkus as well. And it's become very popular as a way to monitor and capture metrics that gives you that almost open telemetry semantic convention like alignment. It also offers many different backends, whether it be Prometheus, Stackdriver, Datadog, New Relic. There's a bunch of different backends there that you can connect to with Micronaut. And the community of Micronaut is also working with OpenTelemetry around the metrics piece specifically to make sure that they're more aligned so that we don't have this situation of anyone who's used Micronaut before with Java finds a huge disconnect between what OpenTelemetry does for metrics with Java, and we want to make sure that the names and how things work is kind of as close as we can get it while supporting something that's cross-language. So Eclipse Microprofile is another kind of standard specification body that offers some aspects here as well. Currently, they have what they call microprofile metrics and microprofile open tracing. Obviously, open tracing is no longer active as an open source project. So there's some work there to figure out what microprofile is going to do around open tracing. And one issue that we found in looking at Quarkus over the last year is that the naming of things in microprofile metrics just doesn't align with how Micronaut does things, which makes it very hard to provide that aggregated view I talked about across services that utilized Spring Boot and Quarkus. There was just no way to mesh the data together. But there are currently future plans to align around Micronaut and OpenTelemetry, but that roadmap still needs to be defined and discussions determined as to what actually that means. Okay, so let's have a look at a demo. Before we get into that, I'll just give you a quick look at the architecture. So it's very kind of simple service perspective because I wanted to focus on the integration with the various pieces. So we have a greeting service that can go out to a name service to get a name to greet us on the website. And then also we send a message off to Kafka as to what name we are saying hello to. And then we have another service, which is just an SSE endpoint to read off Kafka and tell us the name we got from there. So let's have a look at what we have here. So the greeting service, I think that should be reasonably readable. Yeah, that's not too bad. So it's just a JAX-RS endpoint. I have a REST client being injected, which is defined here, which just points to the name service I mentioned on the diagram. And it's just a simple method that returns a string and a text plain type. I also inject a reactive messaging channel here with the names, because that's the name of the topic. And this allows us to, within a JAX-RS resource method, send out a message or emit a message into Kafka. So we have a greeting method which calls the name service to get the name, and then uses the emitter to send a message to Kafka, which consists of the name as the payload, and then get Kafka metadata we'll go to in a second. Essentially, it just creates some metadata to associate with the message that's sent to Kafka. And then from the JAX-RS perspective, we just return the response with a greeting, and it will automatically get wrapped and exported as JSON, because that's the default with Quarkus. We also have another version of that which takes in a parameter of the name so that we can have a name. So in this case, we don't call the name service. We just emit the name to Kafka and then return the name as a greeting. Now the get Kafka method, Kafka metadata, all that's doing is taking the current context from OpenTelemetry. It's not necessarily obvious here, but this is grabbing the context from OpenTelemetry, which contains any active spans that might be present. And then we create a tracing metadata instance from that, saying that this is the previous one. So anything else that we create in terms of new spans should link from this span as a parent. And then we just wrap it in the metadata object. This is something that I'm going to look at from a developer experience perspective to try and make that a little nicer going forward. So as we can see here, the only reference I have to OpenTelemetry right now is in this construction of the Kafka metadata, and there's no mention of metrics or anything like that in here. So that's the greeting service. In terms of configuration, it's obviously the URL of the service. We have the Jaeger collector defined. We have our Kafka bootstrap defined, and the necessary serializer for the names channel that we have. I've defined some resources for Kubernetes to limit the memory usage. And then this is just some container configuration as I'm using micro K8s to deploy this to on another machine. So the name service I'll show you, but it's very just another JAX-RS resource that injects a config property and has a def on if there's nothing in the application properties. It also, and here's the name, so Steve, we should expect to see if we don't pass one in. Also has the Jaeger configuration endpoint and the other same configuration for generating stuff. And then the results service, another JAX-RS endpoint, but this one just produces an SSE endpoint, and then it injects in a channel from reactive messaging with a publisher that takes the names from Kafka as they arrive. So that's kind of all the pieces there. Now, these services have been deployed to micro K8s, and I've been using the container builds to do that. It also required some other setup as well. So let's have a look here. So my micro K8 setup also has the Prometheus operator installed and all the bits there. So Prometheus, Grafana, the Jaeger operator installed, and the Strimzi operator for Kafka and all the pieces there. So I've defined a service monitor for each of the services to say every 5 seconds, use the HTTP port on the service with a path of API queue metrics, which is where all the micrometer metrics will get sent to, and look for matching labels of Quarkus name. So I've got one for each of those. I could probably change that up and do something different so it's only one in the future. I might look at that. And then I also have an ingress. Oops, no, not that one. That one. So I defined some ingress rules to the Kubernetes cluster to say that when we use the hello URL path, then we're going to be calling the Quarkus greeting service. And when we use the results path, we are accessing the Quarkus results service. So that's kind of all the main pieces of the puzzle in terms of setting up Kubernetes, which isn't too bad, all things considered. So let's have a look at, so this is the results API endpoint. And you can see there it's loading, but there's nothing showing up, which is to be expected. So if we go across to Jaeger, let's go back to the root here. Oops. So I've selected Quarkus greeting as the service to find traces for. Right now, it's finding the most recent 20 traces, and they're all from the APIQ metrics endpoint. So we know Prometheus has been scraping the metrics endpoint, and that's been happening on a regular basis, as we see. We'll show that more interestingly later. And then on the Prometheus side, we can execute a HTTP server request seconds count. Notice that it's just the metric name, there's nothing else there. And then we can get all these results, which show, make that a bit bigger. So we have like the Quarkus greeting with the URI of greeting here has been called 4 times. The greeting with a specific name has been called once so far. And then we have like the /q endpoint's been called 1,600 times. The name only 5 times. And so these are all the metrics that we're getting from there. And then on Grafana side, we can see that this is a graphing of the, let me go have a look to make sure I'm remembering right. Yes, HTTP server request seconds count as a rate. And then this is the JVM memory used. So we can see for the memory used, the Quarkus greeting is the green one at the top here. It's hovering between like 95 and 101, 102. The blue one is Quarkus results, and that's kind of in between 90 to 96. And then Quarkus name, because it obviously does a lot less, than the others, is only around 68 to 72. Now, I should point out that these are all using the JDK 11 and JVM. I don't have anything running native here, but if I did, then things would drop significantly. So we have the rate of these microservices, which doesn't show a lot right now. So let's have a look here and see. So this is just the API greeting. And if I refresh this, we get a hello Steve, which is what we expect. And then if we put in a specific name, we get a hello Sentia. And if we go over to the results, oh, why did that stop? Let's try that again. Do that again. And we'll add some other names here. And we should find over here our names. So they went through Kafka and came out the other side into the SSE endpoint. And if we have a look at Jaeger and do another search for, well, that's a bit too big now. Find traces. We'll also narrow it down by greeting to start with. So we can see that we have 3 traces with 5 spans total. So if we have a look at this, we have the API greeting endpoint as the first piece, which is our JAX-RS resource entry point. And it defines numerous tags to give us some detail. So it's obviously a GET request. It returned to 200. The endpoint was API greeting. I'm using a Mac and Chrome as a browser. It's using the proto span format, and it's using the Open Telemetry library from Quarkus. In addition, there's some more process information. So it gives you the host name, IP, and the version of the service, and also the version of OpenTelemetry. So this is using 101. And so we have the API greeting endpoint, and then we also have API name, but from kind of two sides. So we have the span being created on our server side when we make the request. And we can see that this is deemed a client span because we're initiating a client request. And then if we look at Quarkus name, because we're now in a different color and name, so this is all inside the Quarkus service up here. Sorry, Quarkus greeting up here. And then inside the Quarkus name, we have another server endpoint similar to the one we had with greeting. And it's now hitting API name, and it's saying that the client is the Apache HTTP client, which makes sense because we're using the MP REST client implementation to make the request. And then there's similar information around the process and telemetry versions. So there's those two pieces, and then we have these over here as well. So the names send is not exactly great naming on my part in terms of topics, but what this means is that Quarkus greeting sent a message to the topic named names. So yeah, I need to get better at my naming on there. That took like 8.3 milliseconds to do that. And the tags that we have on here saying that it went to the names topic on Kafka. And this was using small I reactive messaging, and it's a producer kind. And similar on the process is very similar information to we've already seen. And then on the Quarkus results side, we can see the span is names received because we're receiving the message from Kafka. Oh, we have some warnings. Interesting. Okay. Interesting. Some clock skewing there. I'll have to look into that. So here we have information saying that it came from the names topic on Kafka. It's petition 0 it came from, and the offset was 2. And this is a consumer kind because we're receiving the message. And so this gives us also an overall view of the time that it took 9.23 milliseconds from when the request first reached the JAX-RS resource endpoint to finishing processing all the way back out, including these processing in Kafka as well. It's pretty crazy to see the time it takes to send and receive these messages on Kafka. So that's when we just hit the endpoint without any particular name. We can go back to, actually we'll issue another one to make sure it's fresh. A little too quick on the trigger there because it does batch up things, so it's not immediate. So here we see our API greeting Mary's trace, which only has 3 spans because we haven't made the call to the name service. So we've lost the 2 spans from the client and the server of our service interacting with it. It's very similar information to we've seen. It will just be on the receiving side. It should be. So yes, we're now on petition 2, and this is offset 5. Another clock skew warning. Okay. And this, obviously, because this is doing less things, it completed in like 5.8 milliseconds. So this is how we can get a view into the tracing side. Let's have a look at the metric side. We saw some metric requests here. Let's see. Let's look at the, oops, didn't want to do that. So if we execute that, we can see the maximum amount of time these requests took. So greeting/name is, wow, that's a small amount of seconds. Let's see if we can see more interesting data in Grafana. So this, as I mentioned, is giving us a view on the HTTP server request seconds count with a rate over 5 minutes. And we can see that, as we saw from Prometheus, we're getting 0.06 of a millisecond response time, total time from the metrics that are being spat out. And likewise, the JVM, the memory usage on the JVMs are fairly stable, kind of growing and then dropping when GC kicks in. So these are kind of the main points around how these can be used. But one of the more important things I wanted to show is that with the code we had here, we didn't have anything to provide this information, particularly the metrics. That's all kind of out of the box with Quarkus by integrating with various extensions. So the metrics we're seeing for HTTP server requests are coming from the Vertex and REST Easy Classic layer to integrate and define those metrics. So there's nothing in my JAX-RS code to define those metrics. So what we're looking to do with Quarkus is enable any framework level metrics to be provided by the framework so that you as a developer don't need to be adding them to your code. You can certainly add code here for specific business metrics, which makes sense. But anything that's to do with the framework should be done by the framework. Let me think. What are some other good metrics we have in here that might be interesting? So we can look at the GCM pause. Oops. Keep doing that. So you can see the pause seconds count is around 100 for a couple of them and up to 200 for the results one. Let's see another one. Memory after GC, and then we'll put that on a graph here. So you can see that the memory is, what's that? 0.16 is, so it's 16% for the greeting and maybe 15%, just over 15 for the results, and then down at maybe 8% for 9% for the name service, because there isn't as much there. Let's do something here. Let's look for something around reactive. Yes. Oh, we have some less REST client metrics there as well. So we can see the REST client request duration seconds bucket. It's actually not that. Let's do the latency count. So we can see there we have a latency of 12,000 as a total count. That's not what I want to do. I want to, let's go over here and add another panel. And oops. Oops. Client. Request. And then we'll do that by, what's a good, okay, yeah, we'll aggregate with the sum by, so you can see the number of requests growing on a regular basis. So these are just some things we have here around integrating with Jaeger and Prometheus and Grafana with observability for Quarkus. So let's go back to the slides. So in terms of Quarkus, obviously that's what I was using here today. We have integrated Micrometer for metrics, and that was added in version 1.8, which was September last year. And as I mentioned, it provides a lot of out-of-the-box instrumentation from various extensions, whether it be database, Vertex, REST Easy, REST client, as we saw, reactive messaging. They all provide some level of metrics out of the box without you needing to do anything in your own application, other than potentially set a flag to activate it. So for instance, with Hibernate, you do have to actually enable the metrics for there, because it is a non-zero cost to collect those metrics. So that's one that we want you to actively choose to enable rather than just having enabled and running into issues. On the OpenTelemetry side for traces, that's in progress. I was running with a snapshot of master here, but an initial version that supports tracing like I've shown here with JAX-RS endpoints, REST client, and reactive messaging will be part of 1.13, which I think goes out next week. And these are all, this is with a exporting to a Jaeger collector. We will be working on an OTLP collector as well. But there's some initial work, additional work I need to do around adding in more functionality for OpenTelemetry traces into things like REST Easy Reactive, the asynchronous types, and various other pieces like that. But hopefully you give it a try out in 1.13 when that's available next week, and let us know how to improve it and what we could do better. And our goal is to simplify getting this working on Kubernetes and give you a lot of stuff out of the box so that you don't have to add it yourself. And with that, I will say thanks very much for having me today, and I hope you all enjoyed it.
Thanks. I'm really enjoyed this topic. It's really helpful for me, and I have some notes that I can include in my project. Yeah. Thank you very much. So we have questions. We have a question from the Constantine. What about footprint? Are there any garbage-free frameworks for tracing? Just if you don't want to produce extra garbage in the runtime of my application.
Well, there is always some cost to being able to do these traces, both in terms of the data that gets passed around internally for a span or trace, but also in terms of collecting that information up before it's exported to a collector. So there will always be some cost there. I'm trying to think, if you wanted to have an integration into existing systems that used OpenTelemetry but not actually do anything yourself, if your application doesn't include an SDK of OpenTelemetry, then it basically becomes a no-op, similar to how open tracing used to work.
Mm-hmm. Okay. Also have a question from the Dmitro. What is purpose difference between Jaeger, Prometheus, and Grafana?
So Jaeger is purely around the traces and giving you a visualization into the traces that it receives. There are other alternatives to Jaeger, such as Zipkin and other different providers that offer similar features. Prometheus is purely the metric side of things with a time series database, and then Grafana is just the visualization of those metrics from Prometheus. There are different providers as well that could be utilized. So I know for the metric side, we can export those metrics instead of Prometheus. We can send them to Stackdriver, Datadog. That might be the main ones so far, but there are some additional registries that Aaron Schnabel's worked on to enable that for Micrometer. And if there's a particular registry that you want to use for metrics or tracing that we don't support, then just let us know and we'll look to add it.
Okay, great. And so from my question is probably that we have some microservice architecture, yeah, and we need to integrate some kind of monitoring. So how we can start for do that?
Yeah, so if you're using Quarkus, it's very easy to get started because, as you saw, there was all these metrics that it produced without you having to do anything from your application code other than having a dependency. And that's a Quarkus Micrometer Registry Prometheus in this case, which is the Prometheus registry. And that's all that's necessary. And then things get activated and it starts spitting metrics out that are accessible at the /q/metrics endpoint. And you can have a look at those. And there's a huge list of metrics that are spat out there about the JVM, about the HTTP requests, and many other things.
Okay, thank you. And probably if I have Spring Framework, do I have any paths how I can do that probably with the Jagger?
Yeah,
Well.
so if you're using Spring, they also do Micrometer for metrics. So that should be an easy transition from anyone who's using Spring to Quarkus or vice versa. On the tracing side, that's Spring Sleuth, and I believe they prefer I think it's Brave is their preference over Jaeger for the actual tracing implementation, but I know they also have Open Telemetry bridge as well into their stuff. So you can use, so you'd be able to have microservices that use Quarkus and Spring that use Open Telemetry for tracing and have them all hook up and provide information.
And probably we don't have any platform-specific stuff probably when we have a Spring that are connected to this stack and also Quarkus application also with this microservice architecture will have the same output.
Yeah, and that's definitely the goal with Open Telemetry and Micrometer is to give us that identical output so we can view things across all these different kinds of services at a high level and they're not mismatched between names and things like that.
Yeah, great. I think it's really great usage for microservice platforms, architecture, softwares, and for in my case as well. So I have some observability, yeah, for my microservices, and it's also have a big impact on business probably that they can take a look on it, what's happened, and yeah, it's really helpful and it's really great stuff. So thank you, Ken. I think I don't have any other questions. Thank you
No,
for
that's great.
your article. Yeah, it's really been great. Yeah.
Well, thanks very much
Thank
for
you.
having me.
Yeah.
Bye.
Thank you. Bye.